Hello everybody, my name's Dave and this is a small workshop that I'll put together to bring in my motors for testing. I bring my water source heat pumps in here for rebuilding. It's a lot cheaper to get them rebuilt, compressors, motors, wherever they may need. Pull them out, get them rebuilt, and reinstall is a lot cheaper than replacing them. But the reason I'm here today is because I want to do a follow-up on the gun range auger motor replacement and failure. It was on a previous video. One of the things I like to do today is take this motor that I removed on a previous service call over to gun range, open it up and take a look at the windings. I do know that when I got there that all the windings was open and I did not detect any ground fault. So I would imagine it was a phase-to-phase short, which kicked the fuse on it. And also I do like to talk a little bit about the follow-up on the call that I had a few days later. And after that, we'll like to run through a few scenarios on this motor. I'd like to talk about a little bit about if we had a motor that was oversized, single phasing startup, what can happen, and what can happen also if you have your overload set at the wrong setting for the application. I'd like to talk a little bit about the previous service call over at gun range. This here is a motor I took out. If you notice on the previous video, I did check the phases, all the phases open. I did not have a ground fault, but I had a really bad burnt wiring smell in here when I opened up the cover. And that pretty much told me we had a phase-to-phase short. Usually if you have a phase-to-phase short, that is a overheating issue, and that's what led me back to take a look at the overload. And I did find the overload was bypassed. I got that rewired and tested, replaced the motor and tested. Everything was up and working. A few days later, the owner called me back and said that it kicked the breaker. So I went back over to the job site, and the first thing I did, I opened up the panel, just take a look at the breaker, make sure that the terminals and all was good inside of there, that there wasn't any damage done from the previous motor failure. And everything was good there. Everything was good at the disconnect. And I was checking over the motor starter. The owner was with me, standing behind me. And I always like when the owners follow me around. That way I can talk to them while I'm working. They can see what I'm doing, and that's less that I have to explain at the end of the job. But also, a lot of times they will, if you listen, they will tell you what has been going on, and you can read into a lot of what they say and help you through your service call. But anyhow, as I was checking the starter, the owner said, "Did you see that arc there?" And I didn't see the arc because I'm up above and he's standing back a little bit looking into it. What it was, where the overload attaches to the contactor is right there. You can see how bad that is burnt. This right here is the actual overload that goes to this contactor. When they set together, it's set together really tight, so you can't really see in there. But if I would have just took the extra time at the previous service call and checked through and tightened all my connections, I probably could have avoided the second call, or it would have brought attention to this, and I probably would have went ahead and replaced it. But probably what kicked the new motor out and kicked the breaker was one of the legs right here was disconnected, so we lost the phase. So we was trying to do a single phase startup on that new motor. That is what kicked out the breaker. Whenever I put this motor under single phasing condition, I'm going to be taking out T2. That's what I'm going to be breaking. That's where I got my switch at, and so I'm going to be breaking out leg T2 to the motor. Anytime you replace a motor, if you can't get exactly the exact same one, the same ratings, even if you do, you still want to check the current on it just to make sure that it's fitting the correct application for the load. Like this, and here's the 460 voltage at the 4.6 amperage. This right here is set according to the nameplate on the motor. But our load, if the motor is running, if you look, our load is only at 2.4. So if for some reason this motor would single phase while I was running under a load, which we're going to do to it, this overload would probably never take it out. I'm going to go ahead and single phase a little bit. So it's going to run at 3.7 right now because it's single phase with also phase in the motor. So it's probably never going to take it out. We can probably sit here and watch our temperature go up a little bit. So they probably just going to run and run and run. It's not going to do any good for the windings. And if it was somewhere where it was get a little bit more load and get closer to that, but not trip it, it's just even going to make it worse for the windings. So what we're going to do now, we're going to take, what I like to do is after I measure what the current draw may be on a particular motor, I like to add 25% of that. So that's what we're going to do at this point. I'm going to go ahead and shut it down, get this back. We know that our current draw under normal condition on this is going to be 2.5. Then we're going to shut it down. We're going to go ahead and set this. So I figure 2.5 plus 25%, that's going to put me right around 3. So I don't know how long it's going to run at that before it trips out, but we'll go ahead and run it and see what happens. So we got it running, doing it at 2.4, but we'll go ahead and single phase it. Single phase it, we're at 3.7. So I don't know how long this is going to take before it kicks it out. There we go. That probably took about a minute, 2 minutes to get it kicked out. But the overload done its job. It protected the windings. So that's the main thing you're going for. That's why I say you always want to check your current going to the motor. Even though your name tag says to set at this, you really don't know what the load is on the motor. So you want to adjust your overload protection according to the load at a particular application. So we went through that scenario. So the next scenario I want to go through is going to be single phase startup on a 3-phase motor. Right now I'm going to go ahead and do the single phase startup of the motor just so you can see how it reacts and where the amperage goes. I got the phase shut off with this switch right here. So we only got 2 phases going to the motor. We drew 27 amps. 27 amps. I don't want to keep doing that because I've got fuses here, and on the other end of it is fuses. So I don't want to pop fuses. I don't want to have to replace any fuses. But as you can see, if it's drawing 27 amps, most of the time you're going to find these on a 3-pole 15 amp breaker. So you know that's going to kick the breaker out. But if you can stop this from single phasing, say it's running and it loses a phase, and then when it comes back around the time to do startup is when it actually goes single phase startup, and that's when it actually draws a high amperage. If you can prevent that by the overload kicking it out when it actually loses its phase during its run cycle, that is a lot less stress on the system than it is for it to go into a high current startup and failure. Because at that point you're putting stress on the windings, you're putting stress on the wiring, and you're putting stress on the breaker. And remember, the breaker is there to protect the circuit. The motor overload, is there to protect the motor. Also, one more thing I'd like to mention for you guys who have buildings. You go around, you're checking your pumps and your starters and stuff like that. Maybe take a little bit of time and take a look at your overload setting. See where it's actually set. I found sometimes guys that get in, they'll crank out the overload all the way up just to keep from having a nuisance trip. Because there are some things out there that trip, and sometimes service guys, they just don't understand what this is for and the protection that it serves for the windings. They'll take and just turn it all the way up, and that way they know they won't get another call for a trip. But the next time out, they may be changing the motor. So it's something to just take a look at. So don't take no time at all. It's a very simple thing to do. But that's about all I can tell you about all of this. I know you may have questions. Hopefully I didn't go too fast. What I want to do now, I want to go ahead and tear this whole motor apart. Take a look at the windings inside of it just to see what happens when you get a phase-to-phase burn, and just see how bad the damage actually is. I guess everybody can see what I'm doing here. Like I said, I already took most of the bolts out, so it's no big deal. Getting it apart. Woo, man. How's that look? Can you see inside there? I'm not sure if you can or not. Kind of hard to see, but it is just completely fried. Both ends are completely fried. I guess that explains why we was open on this end. So that's completely shot. You can see where the rotor is actually pretty burned up. Looks like it was actually seized in there a little bit, actually melted a little bit where the windings melted to it. So it is a little tough getting out. But that there's exactly what happened to a motor once it burns up. So there's several things that will make it burn up. And these overloads set at the wrong position is one of them. One other thing I'd like to mention. Yeah, I gotta get on my bucket to get to my drawing board because I don't have a whole lot of room in where I'm working. But anybody who is working on these starters, even though you shut the power off onto your starter, your relay, and your overload, always check to make sure that if you have auxiliary contacts, always make sure that the power is dead to that also. Because even though this power is dead, this power could be feeding from somewhere else for a control, for whatever. Now, I'm not even going to get involved in what it could be, but always make sure that this voltage is dead, because in our scenarios, this could be anywhere from 24 volt going through that all the way up to 277. So even though the main breaker is off to the starter, always make sure that if you have secondary contacts, auxiliary contacts, that the power is also dead going through them. And that's about all I got to show you for today. I hope you enjoyed the little demonstrations. I hope everybody learned a little something, and thanks for watching.